Okay, here we go with question 2. The transformations R, S and T are defined as follows. R is a reflection in the x-axis. S is a stretch in the x direction with scale factor 3. T is a translation in the positive x direction by 4 units. The curve y equals ln x is transformed by R, followed by T. Find the equation of the resulting curve. Now actually, do you remember the thing here? When we talk about order of transformations, the only problem comes, really, about the order is when they're in the same direction and in the same sense. So if you're stretching parallel to the x-axis and translating parallel to the x-axis, then the order that you do them is really critical, because it makes a big difference. If we're dealing with things in perpendicular directions, so one's a y direction thing and the other's an x direction, then the order that you do them doesn't really matter. It doesn't matter. And actually, I hope I'm right in this, yes. Although that says reflection in the x-axis, we know, don't we, that a reflection in the x-axis is actually a kind of, it's a y direction thing, isn't it? Because it's a vertical thing if you reflect in the x-axis. It is a stretch scale factor -1 in the y direction, parallel to the y-axis. Does that make sense? And t is a translation in the positive x direction. So although they've said transformed by R followed by T, actually it's one of those situations where the order doesn't matter. If you reflect and then translate it on the x-axis, or if you translate it on the x-axis and then reflect, it makes no difference, you get the same result. So actually, although they've talked about the order isn't particularly relevant in doing this, so we don't need to think too hard about it when we put it together. So if we think about the curve y equals natural log of x, if it's transformed with the transformation R, a reflection in the x-axis, as I just said, that's a stretch, scale factor -1 parallel to the y-axis, so that's multiplying the output by -1. So we get minus the natural log of x as our transformation R. And so then we're going to do the transformation T, which was the translation. So we're taking minus ln x, and T is happening to a translation in the positive x direction by 4 units. Well, remember this going right back to those happy core 1 days, that's the inside bit, isn't it? And it always works in the opposite direction. So if we've got a +4, then that needs to be a -4 that goes in the bracket with the x. So this is going to be minus the natural log of x -4, and that is going to be our answer to are we happy with that? It was a little bit sneaky that the order wasn't such a big deal as they made it. Find in terms of S and T a sequence of transformations that transforms the curve x cubed to the curve y equals 1/9 of x -4 all cubed. Right. Well, we've got both of the things going on here. We've got to unpick the order. Now this time we do have that issue, don't we? Because do we? Yeah, we've got S and T, a stretch in the x direction. Well, no, actually, it's not. The order isn't that big a deal for us because they're in the same direction. Oh no, that's right. So the order does matter. That's what I said, wasn't it? Yeah, the same direction. Oh, crikey! Right. So the order is a big deal. Okay. The stretch in the x direction with scale factor 3. Well, look, we've got a 9th here. Well, you know that would mean x would be multiplied by a 3rd, wouldn't it? And we've ended up with a 9th there, so that must have happened twice, because that's a 3rd times a 3rd. So we've got to come up with some combination of 2 lots of x and 1 lot of t. And we've got to think about the order that these would have happened in. Now, the easiest way, I think, to consider what would have happened with this is pick a point and work out where that point has ended up. So for example, the point 0, 0 on the curve x cubed, let's think about the point 0, 0, what's happened to that? The point where it crosses the x-axis. Well, in this one, that point is at x equals 36, isn't it? Because the point where that becomes 0 now is x equals 36. So what's happened to 0, 0 to get it to 36? If you stretch away, in the x direction, that's stretching things that factor away from the origin. So if you carry out a stretch on a curve and it goes through the origin point doesn't change. Does that make sense? So actually, if this was a translation, if this was a stretch, followed by a stretch, followed by a translation, the point that had been 0, 0 would have ended up at 4. Does that make sense? Because it would have stretched it, wouldn't have changed it, stretched it, it wouldn't have changed the point where it crossed, and then it would have moved forward. So it's not S, S, T. It must have been T and then S and then S. Does that make sense? And I know I haven't done any working out to show that. It's all been thinking it through logically. I'm sorry about that, but that would be the answer that we get. And I honestly think that idea of considering a point, considering especially a point where it crosses the axis, and using that as your guide to what's happened, is the way to go with this. So what we've really done is we thought that point, the point 0, 0, has moved to the point, well, if 1/9 of x minus 4 equals 0, that gives us x is 36, so that's moved to the point 36, 0, and think about how that relates to the transformations and the order that they must have been. Is that alright? That's maths.